So continuing with this toolbox on measuring the economic and macro-fiscal impacts of natural disasters, we are moving into GDPs and we'll continue that here. Channels of impact and rule of thumb estimates. Most models assume that capital is one homogeneous commodity that can be instantaneously reallocated towards its most productive use, hence the decreasing returns, with the last unit of capital being the least productive. This is kind of a simplistic economic estimation or expectation, but in reality the remaining stock of capital after a disaster is not optimally allocated. For example, the roads that remain unusable are not the most important roads with the most traffic. The buildings that are still habitable are not the ones hosting the most important businesses, and so on. It's possible to reallocate a large share of capital over medium term, for example, with the most productive firms moving to the habitable buildings, but it's almost impossible to reallocate most of the capital in the short term. The result is a drop in capital productivity on top of the decrease in capital stock. Empirical studies confirm that disasters reduce both the stock of capital and total factor productivity. So we can see this in these papers. Total factor productivity is a terminology which wants to account for all the inputs against all the outputs, instead of taking partial inputs and just focusing on, let's say, a factory that's producing steel. You can just look at cost of labor and total production of steel, but it doesn't account for all the other inputs, so ores, electricity, transportation, emissions control, etc., etc. So that's important to include in the total factor productivity. To capture these effects, this paper by Halagat and Schilb propose a modeling approach in which output losses are estimated as the product of capital losses by the average, not the marginal productivity of the capital. Marginal is like the last dollar, so you have some base costs, fixed costs, and then you have marginal costs, right, from your basic economy. This is expected loss if disaster impacts are purely random and there is no reallocation of capital after the disaster, which is an assumption that's valid over the short term at least. It's equivalent to a situation in which the disaster reduces the stock of productive capital by the cost of damages and leads to capital misallocation, which reduces total factor productivity with an impact on output that is twice as large as the impact from the capital stock decrease. Okay, so read that carefully and listen to that carefully again if you want. In an intermediate case with some reallocation of capital after the disaster, for example, where production equipment is moved to non-affected facilities after the disaster, the impact on TFP would be lower. This approach leads to the following rules of thumb. These are rules of thumb, so just remember that, empirical. For making a quick assessment of potential GDP impacts with discounting at a rate of rho. So that's the investment now and how this value decreases with time. Mu, the average productivity of capital in the country. So each dollar, how much income does it produce, let's say. T is the expected reconstruction time that we discussed before in the last podcast. And delta K, the monetary value of asset losses. The net present value of output losses can then be estimated as delta Y tilde equal to mu delta K over rho plus 1 over T. You can read this paper to understand the details. And the net present value of consumption losses is equal to delta C tilde equal to delta K times mu plus 1 over T divided by rho plus 1 over T. So rho, the discounting rate, is a very random quantity and can be used to reduce, if you increase the discount rate, then you're going to reduce the value of present investment and vice versa. So you have to be very careful that being used as a handle to manipulate decisions. The average productivity of capital mu can be estimated as the ratio of GDP and the value of capital stock, as measured, for example, in the Penn table using permanent inventory method. With standard model calibration, the average productivity of capital is approximately 3 times the marginal productivity of the capital. Okay, so it's better to consider standard average productivity rather than the value of the last dollar. Duration of recovery and reconstruction. In this context, the duration of reconstruction, the variable t we used here, plays a key role in these estimates. Consider first a case where all losses are repaired instantaneously by reducing consumption and directing all unconsumed goods and services to reconstruction investments. This is a scenario where reconstruction capacity is infinite and T is equal to 0. Reconstruction is done instantaneously. In this case, there is no output loss because all asset damages are instantaneously repaired. Everything is back to work instantly. There are, however, consumption losses since consumption has to be reduced to rebuild, and this reduction is equal to the reconstruction value, that is, the replacement cost of damaged capital. In that case, the net present value of consumption losses is simply equal to the reconstruction cost. With unchanged prices, this is equal to the pre-disaster value of damaged assets delta K. So you can see how you can reallocate the boxes in this idealized situation in the empirical relations to count essentially differently, or moving losses in consumption to reconstruction and saying reconstruction didn't cost anything but it came as consumption reduction cost, right? Consider now another case with no reconstruction in which output losses are permanent and all output losses are absorbed by reduced consumption, but no share of income is used for reconstruction. In that case, consumption losses are equal to output losses. Okay, just think through those. With no reconstruction and T is equal to infinity, the loss in consumption at TE is equal to mu delta K, and the net present value discounted at the rate rho of consumption losses is mu over rho delta K. Consumption and well-being losses are thus larger by a factor of around 3. Well-being losses, it's not just consumption. So they are 3 times larger than the value of lost assets in a no reconstruction case. So obviously these simple relations can be used to make decisions on reconstruction time, allocation of consumptions towards reconstruction, and so on. Multi-sector modeling of GDP impacts. These are also more sophisticated approaches that better capture the interplay between sectors or regions. For a recent review, you can look up this paper. Some models are based on input-output linear assumptions, in which producing one unit in one sector requires a fixed amount of input from other sectors, and prices do not play a role, so you can roll. Okay. Even though the IO model is originally demand-driven, it's commonly used to model disasters that are largely supply-side shocks. Extensions of IO models, IO models have been used to include supply constraints and production dynamics within IO model disaster assessments. The IO approach is based on the idea that production system is fixed in the short term and local production capacity is constrained by existing capacities, equipment, and infrastructure. So this essentially says you don't need to import anything to reconstruct or rebuild, bring back capacity, turn on the equipment, etc., which is obviously not always the case. Other models are based on the CGE framework, which I have somehow messed this up a little, which assumes, it's okay, no, don't worry, which assumes that changes in relative prices balance supply and demand. In this framework, there is no rationing in the economic system and markets remain at equilibrium. This in CGE models based on Cobb-Douglas of constant elasticity of substitution function, production technology is not fixed and there is short-term input substitution. These are economic models with economic terminology and jargon. I'm just going through them. If you want more details, you have to follow up on all these extensive references that are provided, but you are understanding what it is saying. Basically, there is the approach of relying on market forces determining the recovery process in terms of reconstruction and return to full capacity and total output, etc. But there are other models where the government plays a heavy role, right? Depends on various factors. In other words, when one input is scarce, production can continue using less of this input and more of others. That's a fairly big assumption there. Economic losses caused by a disaster are smaller in a CGE than in IO setting. In reality, it's likely that IO models are pessimistic in their assessment of disaster output losses because the economy is flexible even over the short term. For example, maintenance can be postponed, workers can do more hours to cope with the shock, or production can be rescheduled. So this is kind of total factor output, total factor productivity inputs that can be somehow managed to keep the total factor productivity at the same level or recovered quickly. It's also likely that CGE models are optimistic even in the long run because prices have stickiness and cannot adjust perfectly because substitution has technical limits that are not always adequately represented in production functions and because their aggregation at sector level makes it difficult to capture the impact of supply chain effects. There are many examples of such calculations following Typhoon Haiyan hitting Philippines. There is a nice paper showing cascades of the impact of perturbed coconut products export from the Philippines into GDPs of many countries across the planet, for example, which shows you all these sorts of impacts. I have cleaners coming in, so I will stop this here and continue in the next podcast. Okay.